I did not really get a chance to listen to it very much, but I did see it.
That's totally up to you whether you want to use that or not. Let's see. Are we going to try it the same way this time where you read the problems?
I believe so. I think that'll work pretty well.
Try it. We could try it the other way. Internet speeds may be better now. If you want to send me there, I'm willing to try that. It kind of depends. If all of your problems can be verbalized, it actually probably works better if you do it from your end.
See, so honestly, looking at this, it doesn't look too terribly difficult. If you just want me to read it to you, I think that'll work.
Let's try it. I think that way works the best. Sometimes that way isn't going to work if they give you like a graph and they want you to come up with the equation of that graph. Then
yeah,
I would need to be looking at that. You wouldn't be able to verbalize that. So.
So the first problem is we're talking about. It just says express in terms of I.
Okay, hold on 1 second. I always forget I have to do this. Okay, go ahead.
So it's root -9.
Okay.
And it just says express in terms of I.
Yeah. Okay. There is a theorem that you want to remember. Okay. Got that?
Okay.
The root of A is the root of A times the root of B. So what we always do is we pull out the -1 first. What's that leave? 9, right?
Just 9, yep.
Okay. That's I. The root of -1 is I. What's the root of 9?
3.
So that is 3I. That's how you do it.
Okay.
Always. In other words, always take the -1 out first. Okay. Go ahead.
That is correct. All right. So the next one is, so there, I guess it's left paren -2 plus 7I, right paren addition, left paren 7 plus 4I.
That's the real part. Yep. That's the imaginary part, and that is the coefficient of the imaginary part. So the first thing you do is just add the real parts. It's -2 plus 7.
It is 5.
Now add the imaginary parts.
You get 2I.
No, we got plus 7I plus 4I.
So it's 11I.
That's all you do. Simple as pie. Always just add the reals and then add the imaginaries. Or subtract the reals and subtract the imaginaries if it's a subtraction problem.
Okay. So it's 5 plus 11I, correct?
Yeah, I think so. I erased it already.
Yeah, that's correct.
Okay. What's the next?
All right. So now it's left paren -6 minus 2I, right paren plus left paren -9 minus I, right paren.
Okay, what's the reals?
The -6 and the -9.
Give me the answer.
So that's -15.
Okay.
And then, isn't it just -3I?
That's it. That's all there is.
Okay.
These are actually quite simple. They're simple as long as you're adding, subtracting. There's one level of additional complexity when you're multiplying. We'll get to that as soon as I give you one. But adding and subtracting is a piece of cake. In fact, if you have some more adding and subtracting to do, you should skip forward. We'll do the rest of them, and then you can do those on your own. You don't have to pay for that. And it's good practice for you to work on doing them on your own. But adding and subtracting is really easy. You just add the reals, add the imaginaries.
All right, so the next question is left paren 10 plus 7i, right paren minus 5 plus 3i, right paren. Sorry, I think I missed one.
Careful of here is that in subtraction. In other words, both terms have to be subtracted. So what is the answer?
So it's 5 plus 2i?
7 minus
Or
3.
4i, I'm sorry.
Okay. Yep. In other words, this negative sign applies to the 5. It also applies to the 3i. So it's 7i minus 3i. That's how you got your 4i.
All right, so now it's going to be left paren radical sign -4, right parenthesis, and then left parenthesis radical sign -25.
All right, so let's translate each one of these. In other words, that's without imaginary numbers, you cannot take the square root of -4. But -4 is the square root of -1 times the square root of 4. -25 is the square root of -1 times the square root of 25. Translate each one of these. What's the left?
So it's I plus 2?
Not plus.
Minus 2.
What are they doing?
Multiplying.
So it's 2i.
2i.
What's this one?
That would just be 5i.
Multiply them together. What do you get?
10i.
10i squared. In other words, when you if that was an x instead of an I, you'd have 10x squared, right?
That says it's wrong.
Well, we're not done yet.
Oh, sorry.
I'm still working you through it. If you had 2x times 5x, you would have 10x squared.
Yes.
Okay. So 2i times 5i works exactly the same. You get 10i squared. Now, I squared has to be dealt with. First of all, if the square root of -1 is equal to I, which it is, then what is I squared equal to?
-i?
-1. Multiply -1 times negative. Here, let me do it. I squared is going to be the square root of -1 times the square root of -1. What is the square root of -1 times the square root of -1? It's the square root of x times the square root of x.
X squared?
just x.
Mm.
What's the square root of 7 times the square root of 7? 7. What's the square root of 11 times the square root of 11?
11.
What's the square root of 9 million times the square root of 9 million?
9 million.
What's the square root of negative 1 times the square root of negative 1?
Negative 1.
Okay, so this 10I squared becomes 10 times negative 1, or negative 10, and that will be the right answer. In other words, you always have to break these down, and whenever you run into an I squared, you substitute negative 1 for it.
Okay.
Okay?
So the next question is left paren 2 plus 9i,
Okay.
right paren, and then left paren 4 minus 8i.
Okay, so here we're multiplying, which is going to be a little harder, but you're going to use FOIL. You know FOIL, what it stands for?
Yeah, first outer inner last.
Yeah, so we're going to do this the same way we would do it if that was an x. In other words, we're going to multiply 2 times 4, then we're going to multiply the outside, and then we're going to multiply the inside, and then we're going to multiply the last. So what do you get when you multiply the first?
8.
What do you get when you multiply the outside?
16i.
You got to multiply it, including the sign.
So negative 16i.
What do you get when you do the inside?
36i.
You need a sign in front of it. If I just write 36i, that
Plus,
doesn't have any meaning.
plus 36i.
It's plus. In other words, it's part of a polynomial or a trinomial or whatever you want to call it. But we need the sign in front of every term except the first one. And what's the last term? Out the last, L-A-S-T?
So that'd be 72, negative 72i.
It's 72i squared.
Squared.
In other words, you do have to multiply the I times the I also. Okay, now simplify this. How much is that? You can always simplify those two terms.
20i, negative 20, or yeah, just 20i.
Plus 20i. You need the plus sign. You can't just write 20i. Okay, and then again, if that's equal to minus 1, what is that whole thing equal to?
Positive 72.
Okay, now add the real numbers together.
So that's 80 plus 20i.
That's your final answer. In other words, complex numbers, always you want them in that format right there. Where that's the real part, that's the imaginary part. B is a real number, it's just the coefficient of the imaginary part. So the only trick of multiplying is converting your I squareds to negative 1.
Okay.
Okay? Go ahead.
So it's left paren 4 plus 4i, right paren left paren negative 4 minus 5i.
Again, just FOIL them. What do you get?
So that's negative 16 minus 20I minus 16I squared.
No.
Oh, I guess it's not squared.
The last term is going to be I squared. That was just the inside term. Was that minus?
So then it's 20I
you're multiplying
minus 20I squared.
you're multiplying that times that. In other words, you always have to include the sign. So what is it? 20 what?
I squared.
Yeah. Now simplify. Always start there. In other words, those middle two terms are always going to be simplifiable.
Yeah. So that's negative 36I.
And then what's that whole thing equal to?
20.
Plus 20.
Plus 20.
Now combine your real numbers.
So 4 minus 36I.
That's exactly how you do them. Every one of them.
Okay.
The only one that's going to give you problems is when they give you a division one. And that's done entirely different. But adding, subtracting, and multiplying is actually as easy as it gets.
Mm-hmm. So the next question is so it's 6 plus 7I squared. So the whole it's really parentheses 6 plus 7I, and then yeah, there you go, just like that.
Yeah, let's just
do
do it that way because we're going to have to do it that way anyway.
Yeah.
Go ahead.
So 36 plus 42I plus another 42I plus 49I squared.
Simplify.
So that's 80. So it's 36 plus 84I plus, oh, so then it would be minus 49.
And simplify. Always starting with the real number.
Set 14, 15.
9 and 6. 49 minus 36 is what?
13.
And it's negative.
Yeah, negative 13 plus
because we have
80.
a smaller number minus a bigger number. Always has to be negative. And
So it's negative 13 plus 84I?
That's in the format of A plus BI. You always want your answers to be in that format. And sometimes you can end up with something like the following. You could end up with 13 plus 84I over 2. Well, that's not in the format of A plus BI. What would it have to be in the format of A plus BI? That top right, how would you convert that to A plus BI?
You'd have to multiply by 2.
No. Split it up into 2 fractions. In other words, you have this fraction and you have that fraction. So it would be minus 13 halves plus 42I. Notice that is in the format of A plus BI. The one above it is not. Okay?
Yeah, that makes sense.
Yeah, and they usually almost always want it in this format. In other words, you're never going to see the very top right that I have circled. You're never going to see that as an answer on a multiple choice, because they're always going to convert it to proper format, which is right below it.
Okay.
Okay, go ahead.
So this is so it's another squared one. So it's 2 plus 3i squared.
Go ahead. Now, you could use the faster method to do this, which is a plus b squared. But with imaginary numbers, it's hardly worth it. Just go ahead and FOIL it.
So it's 4 plus 6i, and then it's 4i.
Hold on. It's 4 plus 6i. Keep going.
Plus 4i.
No. Plus another 6i.
With another 6i.
Whenever you're squaring a term, these two terms are always the same by definition. No matter what the term you're squaring. I could be squaring 3x plus 4y squared. My middle two terms are always going to be identical to one another. You see why? Because that times that has to be the same as that times that.
Yeah.
Okay. So you can do that in one step if you want, once you get, comfortable with it, and just say plus 12i. Now what's the last term?
So it's plus 9i squared or minus 9.
Okay. What's the final answer?
So it's negative 5 plus 12i.
You got it. These are fun, actually, because imaginary numbers really are easy. They're one of the easiest topics in all of math. I suppose until you get to postgraduate level, and then they get a lot more complicated. But
all right. So the next question is 6 plus I over negative 6 minus 2i.
all right. These are a little tougher because this looks like a division problem, but it really isn't. And let me explain that. Lower right, is that a division problem?
No.
No, it's a rationalizing the denominator problem, right?
Yeah.
It's not a division problem. At no point did we do any dividing. Same thing with imaginary numbers. In the same sense that you cannot have an irrational denominator, you cannot have an imaginary denominator. So, since we can multiply any fraction by the number 1, I'm going to multiply the denominator by the conjugate. Conjugate merely means the same two terms, different middle sign. Since I multiplied the bottom by that, I have to multiply the top by that. What that does is gets rid of the imaginary in the bottom. Go ahead and tell me what the bottom is. FOIL the bottom. The bottoms.
So it's positive 36.
Go ahead and do it, the foiling. Minus 6 times plus 2i.
So and then it's minus 12i.
Okay.
Minus 4i.
We're doing this times this. That's the inside.
Oh, so it's minus 12i again.
No, it's not minus. It's a minus 2 times a minus 6.
So plus 12i minus 4i squared.
There you go. Now, because we are multiplying something by its conjugate, in other words, this is the conjugate of that. It's the same two terms, but with a plus sign in between instead of a minus. That's what conjugate means.
Yeah.
Whenever you multiply something by its conjugate, these two middle terms always cancel one another out. So what's the denominator become?
So it's 36 plus 4, which is 40.
That's a real number. That's what we're looking for. So we have a real number as a denominator now. Now we just have to figure out what the numerator is. The numerator requires foiling again. Go ahead.
So it's negative 36 plus 12i minus 6i plus 2i squared.
Okay, simplify that. Go ahead and come up with the real part of it, which is that and that. In other words, 2i squared is now a real number. It's no longer an imaginary number. What real number is it?
Negative. Oh, so it's negative 2.
Okay, combine it with negative 36.
It's negative 38.
Now combine the imaginaries.
It's plus 6i.
And we still have the 40 down below. Can that be simplified?
Can you pull out a 2?
Yep. You can divide top and bottom by 2. Go ahead. Minus 19. Plus,
so it's minus 19 plus 3i all over 20.
Now, is that in A plus BI format?
Yeah.
No, it isn't. We need to separate it into two pieces. That piece
Okay.
and that piece. So what is it?
So it's negative 19/20
That's the real part.
plus 3i
Plus 3/20 I. You want to write it like that. In other words, A plus BI, A is that, and B is that.
Okay.
Okay? So every time you get a complex answer, you want to try to put it in this A plus BI format, and sometimes you have to separate the fraction. In other words, A plus B over C is always equal to A over C plus B over C. So you can always do that step.
Okay.
Okay, what else?
Hold on, let me put this one in here. This is an interesting one.
One last thing about imaginary numbers that I bet's coming next. It's the only thing left, to be honest with you. It's this step right here.
Yeah, I'm pretty sure that's the next. Yeah, I'm pretty sure that's like 5 questions away.
Okay, but in other words, where this is going to come into play is if I said, what is I to the 502nd power? By using this pattern that I just drew, you can answer that. In other words, divide by 4, the exponent. What do you have left over? 2. So this whole thing is equal to I squared, which we know to be equal to negative 1. So what you always do when you see these problems, I to some big exponent, is divide that exponent by 4 and use the remainder. Always. So if it was I to the 503, that'd be the same as I to the 3rd. If it was I to the 500th, then that's the same as I to the 0, which is 1.
So, so like the next question is I to the 23rd.
Perfect.
So you take 23 and you divide it by 4.
You use the remainder. It's the same as whatever the remainder is. What's the remainder?
So it's 3.
Okay, so it's the same as I to the 3rd, and I to the 3rd is minus I.
So, okay. So every time you divide it by 4, you're just figuring out which set in.
You're using.
Whether it's root negative 1, negative I, or 1.
And I could write 100 more following that.
But it follows the same repeating pattern, and that's why you divide it by 4.
Exactly. Every power of 4 just starts replicating itself after that.
Okay.
Is all you really have to remember is this part right there. In other words, every other I to the power of something will be replaced by this, what I have in red. It'll either be I squared, I cubed, or I to the 4th.
Okay.
And you can always get each of those by just doing it. In other words, as long as you know this, that's the magic right there. Then I squared has to be that times that, which is minus 1. And I cubed has to be I squared, which is minus 1, times I, which total of that is minus I. And then I to the 4th has to be I squared times I squared. So it's minus 1 times minus 1. That's how you get the 1.
Okay, that makes a lot of sense.
Yeah.
I might actually just skip through these and.
Well, and that's it. There's nothing more about complex numbers that's complicated. You just covered all of it, or we've covered all of it. So if you want, you can take a shot at trying the rest of those on your own. And if that, it could be.
I think I will. I think I'll finish up that little question set after this.
If you want, but I would try them on your own because I think you have it down at this point.
Yeah. It seems. That seems way easier than I thought it would be.
Most people, that's what they find about imaginary numbers, is they're usually a lot easier than they're expecting.
All right, so the next problem a little further down the list is, it just says solve.
Okay.
So it's left paren 13w plus 7, right paren left paren 6w minus 18 right paren equals 0.
When two things are multiplied together, that being thing number one, that being thing number two, and they're equal to 0, what has to be true?
One of them has to be equal to 0.
So let's start there. Start with the first thing, set it equal to 0, solve for w.
So w equals negative 7/13.
Okay. That's one solution. The other solution is take the other thing and set it equal to 0. What do you get?
18, w equals 18/6.
Which is what? It's 18 divided by 6.
3. So it's, yeah, 3.
So those are your two solutions. And with this kind of a problem, I know that both of those work. I don't have to put them in and check them. There are some situations where you will get two answers and one of them will actually not work. In other words, when you substitute in, usually equations involving radical signs, absolute values, or logs. These are the three things where you will usually have an extraneous solution, and you only find it by checking both of your answers. When you have a simple binomial times another binomial equals 0, well then both of these answers are going to work. If I plug either one of them in, one of these two terms will be 0, and we'll get 0 as an answer. So they both work. But when you have equations that have square roots, absolute value signs, or logs, that frequently will not be the case. And you will have to check both of your answers to make sure that they don't violate domains. A lot of times you'll be taking square roots of negative numbers. You can't do that. Things like that. You can't take a logarithm of a negative number. So that's what makes one of the solutions extraneous, is what they call it. Remember, the rule says that if two things are multiplied together equals 0, only one of them must be 0. It doesn't say they both have to be 0. In this case, they both are 0. And both of these solutions work.
And if it had a radical sign, then we would have to plug it in.
Not necessarily. We would have to check. Yeah, you want anything that's got a radical sign, an absolute value sign, or a logarithm, you want to check both answers. And what you're mainly checking for isn't that it produces a correct answer, it's that it doesn't violate domains. In other words, you can't take the square root of a negative number, you can't take the logarithm of a negative number, or 0. If we get to one, I'll explain further. But in these simple ones like this, you don't generally need to take the time to check both answers.
Okay. Okay, yeah, and they're both correct. Sweet.
Yeah. No, they always are going to be in that case. If I had square roots, if I had something like this, now when I solve it, I got to check both. I'm going to get two answers for x. And I got to make sure they don't violate domains. In other words, I got to make sure that they both leave that as a positive number and that as a positive number. And usually one of your answers will make one of those negative, and so you cross it out and you go with your other answer only.
Okay, that makes sense. So the next question is 3x squared. plus x minus 2 equals 0.
Okay, that's a factoring problem. If we cannot factor it, then we got to use the quadratic formula on it. But I think this is a factoring problem. So how do I begin?
So it's the what times the last number is subtracted to the middle
No,
number.
let's start there. Let's split that up. Got to have something times something, because whatever goes there and whatever goes there, that's the only thing that make up that 3x squared.
Yeah.
It's not a combination of two other terms like the middle term is. The left term and the right term are always. So how do I split up 3x squared?
So one will be a 3x and one will be a 1x, or just x.
Okay, good. Second step.
Numbers that multiply to.
No, that's the third step. Second step, everybody. I have 100 students and 99 of them forget the second step. Seriously. And it's everything in factoring, is knowing the second step. The second step is determine both signs. How can you possibly produce a minus 2 as your last term? What do both signs have?
Both signs are going to be different.
They have to be different. So they can either be plus minus, but because I have a 3x on one side and an x on the other, I also have to allow for minus and plus, because that might be different. Now, you got to throw out all those rules about factors of 2 that subtract to 1. Can't use those anymore. Not whenever this coefficient is greater than 1. All those rules don't apply. The first two steps do apply. You have to split up the x squareds, and you have to determine both signs. Now, what are factors of 2? Over here on the right.
2 and 1.
That's it. So we don't have very many possibilities. I can either have a 2 and a 1. Let's see if that works. How do I determine if that works? Remember that middle term is, I know that the left term is correct and the right term is correct, right? In other words, that definitely produces a 3x squared and a minus 2. But does it produce the middle term? Well, the middle term always comes from the inside and the outside multiplied together and then added. So what's the inside here?
2x.
Plus 2x, put the sign on it. And the outside term?
Negative 3x.
Add them together.
Negative x.
That's not our middle term, is it?
So that would mean we have to switch the signs. So
exactly.
It's
that's all we have.
So
make that a minus and make that a plus. And then this is going to be minus 2x. That's going to be plus 3x. And that'll be plus x. And that's our solution. So now I know that I can erase that. Erase all of this. And that's my solution for factoring. But I still have to solve it. So what's the next step? Two things multiplied together equals 0.
Set one equal to 0 and solve.
That's all you do. What's that solved to?
Uh, 2/3. Negative 2/3.
No, positive 2/3. I'm going to move the negative 2 to the other side.
Oh, you divide by 2. Okay.
So a positive.
Sorry.
Okay, and then how about this one?
X equals -1.
Those are your two solutions right there. And again, because it's a simple quadratic, I don't need to check. Make sure that this works. I'll point it out when we do need to check for extraneous solutions. There are some polynomials that will give you extraneous solutions, but not quadratics.
All right, sweet. So the next question is 2y cubed minus 13y squared minus 7y equals 0.
Okay. They have not taught you how to factor a cubic. So there must be something special about this that we can do. What is it?
Well, we can pull out a y.
Okay, let's do it and see what we got. It's the first thing. And that
so
is
you pull out
the greatest common factor. You want to pull out the greatest. And y is the greatest. In other words, I cannot pull out a 2 because 13 doesn't divide by 2, nor does 7.
Yeah.
So y is the greatest common factor. What's left over?
2y squared minus 13y minus 7.
That's a quadratic. We can factor that. So we're going to have 3 factors on this. Factor that. Step by step.
So you start with the y's in front.
Do it. It's not y and y. Got to split up 2y squared.
Oh, so it's 2y?
2y and y. 2y times y is 2y squared. Remember, this term is always made up of these two terms multiplied together. So that when you split it up, it's really simple. Just split up the y's and figure out what number needs to be in front of one of them. If that was a 4y squared, I could split it up as 2y times 2y or 4y times y. So sometimes you'll get a big enough number that there's some choices as to how to split it up, but not prime numbers. There isn't. Okay, next step.
So it's going to be a negative or subtraction for both.
No, it's not. How can you possibly produce a -7? That's always the next thing to ask. Remember that this term only comes from this term and this term. So that's why you can figure out both signs from that. If two signs are multiplied together, how are they equal to a negative? Only if one is positive and one is negative, right?
Yeah.
So we know that it's plus minus, or again, because we have 2y on the left and only y on the right, if those were the same, if they were both y, then I wouldn't have to write the minus plus. But because they're different, I do have to check this part of it also. How do you factor 7?
7 and 1.
Let's try that. Tell me what that produces in the middle.
Uh, 7y. And then -2y on the outside.
Combine those.
It's 5y.
So that's not right. Okay? Now, not only do I know that that's not right, but it also would not help to just change the sign to a -7 and a +1. Because I know as all that does is it gives me the same number, opposite sign. So the other option is let's move the 7 down to there. Let's move the 1 down to there. And let's erase them from there. And let's try this. Does that work?
No, because it'll just give you the opposite sign.
I'm sorry. I meant to say this. meant to say switch them.
Yeah. So if you put 7,
Yeah.
then it's 14 and 1y, which would give you the -13.
Yeah, there's no point in trying what I just did because I know it gives me the same number, different sign, and I don't have the number. So I switch the numbers, and what does that give me?
That gives you the -13y.
Yeah, and if it gave me +13y, then I would just move the 1 down to the negative sign and the 7 down to the positive sign.
Yeah.
But since it gave me the right answer, I have my final factoring. Now, how many solutions are there?
There should be 3 because it's a cubic, correct?
Exactly. What are they?
So y equals 0.
Good. That's the one most people forget. Whenever that variable is out there all by itself, they don't think of 0 as being one of the answers.
So then it would be y equals a -1/2.
Okay.
And then y equals a +7.
Yep, that's it. So whenever they give you a cubic, look for something that you can do to turn it into a quadratic. Because that's usually going to be what you have to do. Because actually factoring a cubic is extremely difficult. That's where you have the P over Q and the rational factor theorem. I think we did cover that at one point. But factoring a cubic is hard.
Yeah.
Unless you have a greatest common factor that you can pull out, and then you're left with a linear and a quadratic, which is easy to do.
All right. So now it wants me to use the quadratic formula for this one.
What is the quadratic formula? Start there. See if you can do it from memory, because most of the time you're not going to be able to look it up. If you were taking the SAT test, you'd have to do it from memory.
It's like y equals the...
Always x equal.
X equals the
doing is solving
square root of... Oh, man.
Whatever it takes to memorize that, try to do it. Now, here's the way I memorize it, or here's the way I think I can teach people to memorize it. This comes in 2 parts, right? There's that part. What else is minus b over 2a equal to? The vertex x coordinate.
Yeah.
Is equal to minus b over 2a. So if you remember this, apply it when you're working out the quadratic formula. And this part of it also has its own word. That is called the discriminant. So you're taking this first part, minus b over 2a, and you're adding and subtracting the square root of the discriminant. That's kind of the way I remember it. The discriminant being b squared minus 4ac. So tell me what a, b, and c are.
A is the 7x squared.
Nope, it's just the coefficient. Never includes the variable. Ever. What's B?
Would be -10.
And C?
Is -3.
That's how you do it. You just pull off the coefficients, and there's your A, B, and C. Plug them into the quadratic formula, simplify, and you have your answers for what x is. And this plus or minus gives you two answers. One of them is plus, one of them is minus. So, what's the function that they want you to factor that's not factorable, therefore you have to use the quadratic formula?
So it's 2x squared plus 6x equals 5.
I'm going to move that 5 over and make it equal 0. Because in order to apply the quadratic formula, it has to be equal to 0. You have to have all terms on the left or on one side.
Okay.
Okay. So, could I factor that? No. Well, I don't know if I can or not, to be honest with you. Without trying, I could spend a few minutes trying to factor it, but the fact that they said solve it using the quadratic formula, there's no point in even trying to factor it. Let's just go ahead and we're forced to use the quadratic formula. What is it again?
X equals minus b over 2a.
That's fine. No problem doing it this way. I go back to the numerator.
So that it's plus or minus the square root of
Discriminant is
b
squared 4ac.
AC. Okay.
Okay. So now we need what A, B, and C are.
So A is 2, B is 6, C is -5.
Now let's plug them in. And you should always do it this way. Don't do anything in your head here. Seriously, you're just asking for a mistake. So the best way is to just plug it in. If it's a negative number, plug it in parentheses. So what's
okay? So it'd be -6 plus or minus the square root of 6 squared.
Okay, I can do that one in my head. Okay.
36, yeah. Minus
and
4.
This is where I think you should always do it this way. Because you almost always have extra negative signs, and you're going to have two negative signs here. It's very confusing. So what's A? A is 2. C, it's -5. Now, this is where everybody can make a mistake really, really easily. And the way to avoid making a mistake is to solve that first. What is that? What is 4AC equal to? Do not include this.
-45?
It's 40. 4 times 2 times 5 is 40. Negative 40.
Oh, 40.
Negative 40. And that's why it's important that you just do 4AC. Do not include this negative sign yet. Figure out what 4 times 2 times -5 is. That's -40. And now we have 36 minus a -40. That's actually 76. So our answer over here on the left is -6 plus or minus the square root of a positive 76 all over 4. You with me? How I got there?
Yeah.
You can see why it would be confusing, because that negative sign almost looks like it should just cancel out that negative sign there. And it does not at all. And that's the mistake everybody makes. So always try to do your 4AC separately, and then just subtract that from b squared. Okay? Now, that's not a final answer. Why isn't it?
Because it's not, I mean, that's not a solution.
Well, it is. It's just not simplified. We can simplify square root of 76. Factor that. Is there a factor of that that's a perfect square number? Like 4 and times 19. 4 times 19 is 76, right?
Yep.
So root 76 becomes 2 root 19. So this answer now becomes minus 6 plus or minus 2 root 19 all divided by 4. And now what can I do? I can simplify it further. I can't simplify root 19. That's a prime number. But I've got a 6 in the numerator, a 2 in the numerator, and a 4 in the denominator. So what can I do?
Divide everything by 2.
Do it. What's the final answer?
So it's negative 3 plus or minus 1 root 19 over 2.
There you go.
So it's really plus or minus, there's negative 3 plus or minus root 19 over 2.
That's the final answer. And that is 2 answers, because one of them is minus 3 plus root 19 over 2, and the other answer is minus 3 minus root 19 over 2.
Okay.
So you have a quadratic, you expect 2 answers, you get 2 answers. Every now and then you'll only get 1 answer. If this discriminant is exactly equal to 0, then your answer will be minus b over 2a. And you'll only have 1 answer. But that's what happens. That's what has to be the case for you to only have 1 answer. And you would have 1 answer with a multiplicity of 2. But most of the time, as long as there's some number in that radical sign, you're going to have 2 different answers. And here, one last thing. The fact that we have a radical 19 there means that I could not factor that. If I was able to factor that, I would have whole numbers everywhere, such that this answer would be 5 or 7, or 5 or minus 7, something like that, but it would not have a radical. When you use the quadratic formula and you get a radical in your answer, that tells you it was not factorable.
And that's why we had to use the quadratic formula.
Yeah. I didn't spend any time trying to factor it, but I didn't know that. If you put a gun to my head and said, solve that, I would have probably spent a few minutes trying to factor it. And then when I discovered I couldn't factor it, then I would go to the quadratic formula. The quadratic formula always works, whether you can factor it or not. Even if I would have been able to factor it, the quadratic formula is still going to give me the same 2 answers.
Okay.
Okay? So you can always use it. It's just usually as the harder method. If you can factor it, factoring is usually easy.
Oh.
Also, don't feel like you have to take up the 2 hours, Russ, just because you signed up for 2 hours. If you're done after 1 hour and 20 minutes, just tell me and we'll just chalk up 1 hour and 20 minutes. You know what I'm saying?
Yeah, I'm looking at the rest of these, and they look pretty like we'd have to switch screens around.
Well, that's easier probably said than you think. We can try that if you want. Do you have a graphing one where you can't verbalize it?
Well, I mean, let's see. So this one it's got a lot of words in it. Find the discriminant. Where
we
we
can
go.
do that.
For the following, find the discriminant of b squared minus 4ac, then determine whether one real number solution, 2 different real number solutions, or 2 different imaginary solutions.
Let's do these. Let's do it. Give me the function.
So it's 6x squared equals 8x plus 7.
Okay, the first thing we have to do is get it into standard format. You cannot tell what A, B, and C are until it's in standard format.
Okay.
So, now what's A, B, and C?
A is 6, B is -8, and C is -7.
Now, the discriminant is this. It's not the square root of that, it's that. So, what is the discriminant?
So -8 squared minus 4 times 6 times -7.
Okay?
Or parentheses -7.
Let's, how do we do this? How do we simplify this? Start with -8 squared.
So that's 64.
Now, leave that subtraction sign there and do that part only next. Use your calculator if you like. This looks like it needs a calculator almost. 24 times 7. What's 24 times 7? That's 148. Here, let me do it on paper. 24 times 7, 168. So what is that?
168 minus 64 is 1.
Hold on. What is 4 times 6 times -7? Need sign first.
-168?
Sure. In other words, I've got one positive number and one negative. I've got two positive numbers and a negative number. So that's always going to be a negative number. And that's why I insist on you doing it this way, because now it's really just adding those two numbers. So what is the discriminant? Okay.
That's 330. No, 232.
Now, here's the thing. The only thing you need to know, if the discriminant is greater than 0, then you have two real solutions. If the discriminant is less than 0, you have two imaginary solutions. And if the discriminant is exactly equal to 0, you have one real. Those are the things you have to memorize right there. And then you just have to calculate the discriminant. You don't care what the number is, you just care whether it's plus, minus, or 0. So the moment we saw that, we knew it was plus. No, that had to be the answer. We don't actually have to figure out that it's 232. We just have to know we're adding two positive numbers. We're going to get a positive answer. That means two real.
Well, so it says, what is the discriminant of b squared minus 4ac?
You do have to come up with a number. Okay, it's 232.
All right. And it does have a second part. What is the nature of the solution? So this is where it would be a two real.
Yes.
There are two different real number solutions. Okay,
yeah,
sweet.
Because the discriminant is positive.
All right.
And a different one. Next one.
Find all the zeros of the function.
Of this function?
No, of a different function. So it's f of x equals x squared minus 5x plus 5.
When they say find the zeros, what am I setting equal to 0?
X.
This is where I really hate your computer. That is not what that typically means. When they say find the zeros of a function, they're saying find the x-intercepts, which means
So it's where y would equal
y
0.
equals a 0. And this is where you're going to have to use the quadratic formula again. There's no combination of 5 and 1 that results in a middle term of minus 5x. So, quadratic formula again.
Oh man. X equals negative b over 2a. Back in the numerator is plus or minus the square root of the discriminant, which is b squared minus 4ac.
There you go. I'm just going to keep asking it over and you'll memorize it.
Yeah.
Okay. So, what's minus b?
So minus 5.
What's a?
A is 1.
B?
Negative 5.
What's c?
Positive 5.
What's minus b again?
Positive 5.
First time you said negative 5.
Yeah. Yeah.
B squared. This one you can go ahead and do in your head because it doesn't matter if it's positive or negative. When you square it, it turns out positive. So just square 5.
It's 25.
Okay. Now the rest of it, I really do think you're better off always doing it this way. C is 5. Do that. All over 2. So what do we have? In other words, multiply those and then subtract it from 25. What do you have?
So it's just 5 plus or minus the square root of 5 over 2.
That's your final answer because nothing can be simplified. So to me, that's what it means to find the zeros. Now, you had some internet problems where they had a different meaning on that. Sometimes they find the zeros and they meant set x equal to 0. I didn't like it when I saw it the first time. I still don't. That should have a definite meaning, and it shouldn't be flexible. To me, when you find the zeros of a function, you're finding the intercepts, the x-intercepts, which means you're always setting y equal to 0. Okay?
Yeah.
All right. Did that, well, put that answer in and tell me if it was right. Because we'll know whether or not they're talking about the x-intercept.
Yeah.
Okay.
That's correct.
So they were talking about the x-intercepts this time. At one time, they weren't always. There were times where they meant to let x equal to 0 and figure out the y-intercept. And they were calling that the zeros of the function.
Yeah.
It shouldn't have been.
All right, so the next question is find the zeros of the function. It's f of x equals 3x squared minus 7x minus 5.
Let's see, 5 times 1, 1 times 3 is not going to give you a 7. So again, this is not going to factor nicely. So, give me the quadratic function again.
Negative b plus or minus the square root of b squared minus 4ac over 2a.
All over 2a, yeah. They actually teach a song for this. I don't know.
Yeah.
I was never taught that song, but most of my students were taught a song. Okay, so let's substitute.
So it's positive 7 plus or minus root 7 negative 7 squared, which is 49.
Okay, and do that part.
Minus 4 times 3 times negative 5.
And you almost always have this situation where you're staring at two minus signs here. Only
Yeah.
one of them means subtraction, the other one means a negative 5. So if you don't do it properly, you can easily make a mistake. And it's quite easy to forget the 2a also. That's a mistake I make frequently, is I don't put the 2a underneath. I just write the numerator and I go on my merry way. Okay, simplify this.
So it's plus 7, so it's 60.
Okay,
Or 49 minus 60.
Okay, it's minus 60. So what does that make?
Yeah.
Total number inside the radical.
11.
It's 49 minus a minus 60. That's why I insist that people do it this way, so that you cannot make that mistake.
So that's 109.
Yes, positive 109. You see why I do it this way? Is because I want you to come up with that number all on its own, and that number is negative 60. And then, because I still have a subtraction sign there, I am subtracting a negative 60, which is the same as adding 60. Now, can you reduce square root of 109? Here's what, in order to reduce it, you would have to find a factor that is one of these numbers over here on the left. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. I'm not finding another number bigger that's going to go into 109. So
Yeah.
one of those numbers go into 109. If it does, then it can be reduced. If it doesn't, it cannot be. Can 4 go into it? And 1 doesn't count. So does 4 go into it?
No.
Instantly, you know no, because it's not an even number. 4 only goes into even number. How about 9? Digits would have to add up to a 9. Do they add up to 9?
No.
16 has to be an even number. 25, it would have to end in 0 or 5 to be divisible by 25. 36, no, 3 times 36 is 108. Almost, but not quite. So, it's not simplifiable. That's your final answer. Now, they wanted the answer on this one, as well as whether or not what the discriminant is.
Now this one just says find the zeros.
Okay. It's 7 plus or minus root 109, all divided by 6. And they let you put it in that way, plus or minus?
No, I have to enter it twice.
Oh, do you? Okay. As long as you know that it's 7 plus, first answer, and 7 minus the second answer. And because the discriminant is a positive number, we know that it is 2 real answers. 2 real zeros, not imaginary. In other words, if that number is negative inside the radical, then you have 2 imaginary answers. And if it's exactly 0, then your answer is 7/6.
All right, I think I might be able to do some of these. Look like I might be able to do them on my own, and a couple of them look like they're going to be too difficult for me to read to you.
Okay.
I'm okay with the hour and a half that we did. If you're satisfied as well.
I didn't hear what you just said. I can make you the presenter if you want to take a look at some of those that you're not going to be able to verbalize. You want to try it? See if it works?
I think I'm pretty well puckered out at the moment. I got a lot of math in, and I feel like reading and switching around is just going to be a bit of a hassle for me at the moment.
I think you can probably do the ones you think you can do. I believe you probably can do them without my help, and that's probably the best next step for you to start taking. Is get to a point where you understand it, you understand how to do them. That's when you should try doing some of them on your own.
Yeah.
One thing, you don't pay for that. So.
Yeah.
But for another, you need to get to that point where you can do them on your own.
Definitely. Awesome. Well, I do have work tomorrow, and I believe I'll have work on Saturday, but I will see you on Sunday.
Sounds good. I still got your 2 o'clock down, right? Is your standard?
Yep, that sounds like the plan.
Okie doke. So we'll see you on Sunday.
Awesome. Thank you, David. Have a good night.
You too, Russell. Bye-bye.
Bye.